If we want to solve the transient process, similar to the previous analysis of resistive circuits, we must list the equations. There are two basic elements for listing equations, that is, element constraints and topological constraints. As we learned in lecture 46, element constraints of the capacitors and inductors are differential equations or integral equations. So equations we list here are not only algebraic equations, but they must be a differential integral or differential integral equations. Here we take a simple example containing a capacitor, a resistor, and a voltage source. For such a circuit, consists with three elements in series. Obviously, we should use the topological constraint KVL. The voltage drop is equal to that voltage drop, so UR plus UC is US. By using the element constraints, we know that UR is equal to I times R, due to the associated reference directions of the voltage and the current. For the capacitor, we know that I is equal to C duc dt, which is a relationship between U and I under the associated reference directions. By solving three simultaneous equations, we can get that RC duc dt plus UC is US. It is a first-order constant coefficient linear differential equations about the variable of UC. So we finished writing equations of the circuit. It is the equation for the circuit. The difference is that all the items of the equation divided by the RC item of duc dt. In addition to such a circuit, we can also list the equations for more complex circuits, such as a circuit containing two energy storage elements. It's a circuit that a capacitor, inductor, and a resistor connected in series, assuming switch is closed when t is 0. According to the reference directions of the variables given in the figure, we know that UC plus UL plus UR is 0. We know that UR is Ri. It must be equal to RC duc dt. For UL, it is L di dt. It must be equal to LC d square duc dt square. By combining these equations, we know that LC d square UC dt square plus RC duc dt plus UC is 0. Similar to the previous habits, we set the coefficient of the highest derivative as 1. That is d square UC dt square plus R over L duc dt plus 1 over UC. UC is equal 0. For these two equations, the highest order term of the upper equation is first order derivative of variables, and the highest order term of the lower equation is the second order. So we call it the first order and it the second order. That is to say, if the equation of a circuit is a second order differential equation, then it is known as a second order circuit. The first order differential equation corresponds to the first order circuit. It should be pointed out that the equation of the dynamic circuit containing two energy storage elements sometimes is a first order, so it also is a first order circuit, but that isn't always the case.